Up next, we will have a very special guest. Galileo will be coming into the studio to have an interview. Welcome back to the Gravity Games 2015. I'm your host, Ebenezer Fox, and today we have a very special game lined up for us. But first, an exclusive interview with the founder of the games himself, Galileo Galilei. Welcome to the studio, Galileo. It's nice to have you. So, explain to me, what exactly was your hypothesis for this experiment?
My hypothesis was that two objects will follow the exact same acceleration, independent of the mass of the objects. The track Galileo used was 14 cubits long, about 5.5 meters. One end of the track was raised about 1/2 meter. It had a groove cut down the center of it, and was lined with parchment paper.
A round bronze ball was rolled down the track. A water clock was used to measure the time it took for the ball to roll down the distance of the track. Fractions of the total distance were also measured.
A large vessel of water was placed in an elevated position. To the bottom of the vessel was soldered a pipe of small diameter, giving a thin jet of water which was collected in a small glass during the time of each descent. The water collected was weighed after each descent on a very accurate balance.
The differences in ratios in the weights give the differences in ratios in the times. Now we have some guests in our studio. Some of the students who were actually involved in the experiment have joined us today. Welcome, guys.
Thanks for having us.
I'm glad to be here.
Thanks for coming.
Alright, so let's get started. Let's start off with what kind of track you used and how did you decide to use it?
We actually had two different tracks. One was made of steel that formed an angle where the ball could roll down. The other one was made of wood and was lined with parchment paper.
So you say that there were some similarities between your experiment and Galileo's. Were there some differences, maybe in materials or how you did it?
Well, I would say that we had a couple differences. Like, we had a steel ball instead of a bronze ball. We used for our water clock, a glass jar that had a spigot. And then we measured all of our results on a triple beam balance.
You mentioned parchment paper. I have a question. How does the parchment paper affect the experiment?
So we actually didn't use parchment paper the first time. We used the wooden track because it slowed the ball down quite a bit. But then we found out that slowing the ball down gave us more accurate measurements. And then the parchment paper was able to give us ratios that were closer to the actual values.
So what were the results of the steel track, and why did you end up using the wooden track?
Well, the steel track worked well because the friction on the ball was constant down the whole track. But when we used the wood track without parchment paper, it was kind of rough and the ball didn't have velocity the same. So when we used parchment paper, it made it really smooth, but even though it slowed it down, it still had the same friction and everything down the track, and it worked the best. So.
Thanks for coming on, guys.
Thank you.
Thank you.
Appreciate it.
Alright.
We ran 5 trials for the steel track, the wood track, and the wood track using parchment paper. We then took the average of the results. You can see on the screen the data sheet of the results we got using the parchment trials.
Galileo did not have a good way to measure seconds, so he measured the amount of water that would flow through a pipe for each distance and then weighed the water. We measured our time in a similar manner. Galileo found that the square of the amount of water that flowed through the pipe was proportional to the distance the ball rolled. On this slide, you can see that on a steel track, if a ball rolled 2 meters, the amount of water that flowed into our glass was 98.5 grams, and for 1/2 meter, we got 47.2 grams. If it had been right on, it would have been 49.25 grams. For the wood track, if a ball rolled 2 meters, the amount of water that flowed into our glass was 162.5 grams, and for 1/2 meter, we got 95.5 grams. If it had been right on, it would have been 81.25, which is quite a bit off. For the wood track with parchment paper, if a ball rolled 2 meters, the amount of water that flowed into our glass was 166.6 grams, and for 1/2 meter, we got 86.64 grams. If it had been right on, it would have been 83.3, which is pretty close. We took the data and converted everything to percentages so that it would be easier to compare the data for all 3 tracks. On this graph, the blue line represents freefall, which would be the ideal graph for the data from the 3 tracks. The data from the wood graph is represented by the green line. The data from the steel track is represented by the red line, and the data from the wood with parchment is represented by the purple line. Overall, the graph for the data for the wood track with the parchment paper was closest to the ideal. As you can see, the data for the track with parchment paper is almost right on a graph that represents freefall. The wood track without the parchment paper was simply too rough, and so the friction was not constant. The steel track was good, but the parchment paper on the wood slowed the ball down enough to be able to make more accurate measurements. Another way to graph the data would be to look at the acceleration constant derived from the data. Looking at this equation, we have values for time and distance, so it was a somewhat easy matter to solve for k. For free fall, we know that would be a divided by 2, where a equals 9.8 meters per second squared. If our data were ideal, we would see a straight horizontal line representing the value k for each set of data. On this graph, the blue line represents the ideal of free fall. Again, the red line represents the data for the steel track, the green the wood track, and the purple the wood track with parchment. The data for the wood track with parchment, again, is closest to the ideal. We have included this slide which shows a summary of all our data for anyone interested. One of the things that could have been done to make the experiment more accurate would have been the practice of the timing between the person letting go of the ball and the person turning the water on before making actual measurements. It was pretty tricky coordinating the timing between the two. Just taking more measurements than 5 would have been better. Galileo used a longer track, and that would have helped to get more accurate measurements. The spigot on the glass jar was somewhat cumbersome to use. Using a pipe, which we could have stopped up with our finger, might have given more accurate results.
I wish I found some better sounds no one's ever heard. I wish I had a better voice that sang some better words. I wish I found some chords in an order that is new. I wish I didn't have to rhyme every time I sang. I was told when I get older all my fears would shrink, but now I'm insecure and I care what people think. My name's Blurry Face and I care what you think.
Yeah, the problem with the, I think,
Stop!
well,
Garrett.
with the walking around.
Hey, get out.
That is why I
Let's film Abby.
This is why video.
Look at your teeth. This is going on the video.
Up next, a brief description of Galileo. Today, an exclusive interview with Galileo himself as well. I'd like to oh, well, that happened. Mr. Galileo Galilei.
Yes, quite. Can I help you?
Oh, well, I was just wondering.
What kind of track did you? 3, 2, 1, go.
So bad. Wait.
He has a weird, like, weed.
Awkward.
Here comes Santa Claus.
Master.
You look like Leonardo da Vinci and Santa Claus mixed. Look
And an angel or something.
at your shirt.
Great. Okay. This is great. 3, 2, 1, go. Dude, you actually slapped me.
Welcome back to the Gravity Games 2015. Today we. Okay, go. Thanks for coming into the studio today.
You're supposed to ask.
Welcome to the studio, Galileo. It's nice to have you.
This and then shake your shoulders.